Hello, my name is Yadi Garcia, and my project focuses on the comprehension of the thermal processes, morphology changes, and ion transport that occur in electrolyte composite materials. These processes are mediated by interfacial regions, and their understanding will boost the design of the energy storage materials with application in rechargeable lithium-ion batteries. Here we study composites between an organic uniplastic crystal and polymer nanoparticles. And we're expecting that these composites will take advantage of the properties of their main components like plasticity and mechanical strength. We prepare these composites by adding 20 volume% of polymer nanoparticles with 25 and 100 nanometers to an organic uniplastic crystal using a solving casting method. After that, we determine the thermal properties, the morphology, and the ion dynamics using the differential scanning calorimetry, an optical microscope, and solid-state NMR, respectively. From the thermal analysis and comparing the endothermal peaks of the pure YPC and both composites, we observe that these peaks change. The interfacial regions formed in these composites promote ordered local YPC structure after adding nanoparticles with 25 nanometers. And we can observe that from the sharper and higher intensity peaks. And a different behavior was observed after adding bigger nanoparticles. This agrees with the results observed from the morphology studies. In this case, after adding bigger nanoparticles, we observe a higher disruption of the OIPC crystals. And also, this means that we are promoting the formation of more structural defects in this composite when compared with the composite with the smaller nanoparticles. From the ion mobility studies of the lithium ion, we observe that the lithium ion mobility is average in the composite with higher nanoparticles. And while in the composite with the smaller nanoparticles, we observe two different components. The broad peak corresponds to a crystalline region and low ion mobility, while the sharp component corresponds to a more disordered region and fast ion mobility. From these results, we can conclude that the interaction between the OIPC and the polymer nanoparticles form interfacial regions that modify the thermal properties of the OIPC, increase the structural disorder, and promote higher lithium ionic dynamics in the electrolyte composite. However, a higher disruption of the crystalline structure was observed in the composite with nanoparticles of 100 nanometers, and it leads to a higher mobile fraction of the lithium ions in the interfacial region. Thank you.